Here are the solutions to the classwork about derivatives in factored form. For problem number 3, we're trying to find the derivative of the square root of 3x minus 2 times 3x plus 2 quantity squared. Here we're going to use the product rule since those two forms are multiplied by each other, and we also need the chain rule since the polynomials are raised to a power of 2 and to a power of 1/2. I label f of x 3x minus 2 raised to the 1/2 power. When I take the derivative of that, I use the chain rule, so 1/2 comes from the power, my polynomial 3x minus 2, subtract 1 from the original power, and then this 3 comes from the derivative of the inside, that's the baby. Then we have g of x is equal to 3x plus 2 quantity squared. Use the chain rule again. 2 times 3x plus 2 times 3, which is the derivative of the polynomial. So I have f times g prime plus g times f prime. And when I rearrange all of my polynomials, I get 6 times 3x plus 2 times the square root of 3x minus 2 plus 3 over 3 times 3x plus 2 quantity squared over 2 times the square root of 3x minus 2. I need to combine this into one fraction, so I need to multiply by the common denominator. The common denominator is 2 times square root of 3x minus 2. Multiply the top and the bottom by that. The 3x minus 2 square roots are going to simplify into just 3x minus 2. And then I'm looking for the common factor on the top. The common factor on the top, I can pull out a 3 from both of these guys and a 3x plus 2 to the first power. So factor out my common factor of 3 times 3x plus 2, I'm left with 4 times 3x minus 2 plus 3x plus 2. Simplify the top by distributing. I get 3 times 3x plus 2 times 15x minus 6 all over 2 root 3x minus 2. This guy has one more common factor. Common factor is 3. So then 3 times 3, that's how I get the 9 here. 3x plus 2 comes from the common factor. This is what's left over from pulling the common factor out of this term. And then my denominator has been 2 square root 3x minus 2. Question number 4 is a factoring problem. So we had 1/2 x squared plus 3 to the negative second power, x plus 7 to the third, minus 4x times x squared plus 3 to the negative 1 power, times x plus 7. My common factor is going to be 1/2. Can go into both 1/2 and negative 4. X squared plus 3 to the negative 2 power, and then x plus 7 to the second power. So when I pull out those common factors, I'm left with x plus 6 minus 8. This 8 comes from 4 divided by 1/2. 8x, quantity x squared plus 3. When I distribute on the inside, I get negative x to the third power minus 23x plus 7. And I'm going to bring these two guys into the denominator. So the 1/2 is in the denominator alongside x squared plus 3x to the negative 2. Make that power positive by bringing it into the denominator. Question number 5. Find the equation of the tangent line at 2, 13 for the function f of x equals 6x plus 1 over x minus 1. We're going to use the quotient rule here since we have a fraction. My f is 6x plus 1, f prime is 6. G is the denominator, x minus 1. G prime, the derivative of x minus 1, is 1. So we do g times f prime minus f times g prime all over g squared. When I distribute and simplify the top, I get negative 7 over x minus 2 quantity squared. The reason we found this, the derivative is the slope of the tangent line at any given point. So if we want the slope of the tangent line at 2, you need to plug in 2 into your derivative to find the slope of your tangent line. When you plug in 2, you get negative 7, 2 minus 1 squared equals negative 7. So this is the slope of the tangent line at x equals 2. When we want the equation for the tangent line, we plug the slope and the starting point, so this 2, 13, into point slope form. Y minus y1 equals m times x minus x1. When I distribute and simplify, the slope of the equation of my tangent line is negative 7x plus 27. Question number 6. Find the point at which the graph of f of x squared over x minus 4 has a horizontal tangent line. A horizontal tangent line means the derivative is equal to 0. So we set up the quotient rule first. F of x is x squared, f prime is 2x, g of x, x minus 4, g prime is 1. G times f prime minus f times g prime all over g squared. So now I have f prime of x is equal to x squared minus 8x divided by x minus 1 squared. The derivative is going to be equal to 0 when the numerator is equal to 0. We can't have a denominator equal to 0. That'll give us a different kind of tangent line. So all we care about is when the numerator is equal to 0. I factored this guy, x minus 8. My two x locations are going to be x equals 0 and x equals 8. Those are the two times when the tangent line is equal to 0. But I wanted the points. In order to find the points, I plug 0 into the original function. I get 0. There's my first coordinate point at 0, 0. I plug 8 into the original. So I get 64 over 4 is equal to 16. So the second location is 8, comma 16. Finally, find the rate of change for the demand function. If the demand function is x equals 300 minus p minus 4p over p over 3, we're looking for the rate of change when p is equal to $5. We need to do two different things here. The derivative of 300 is 0 since it's a constant. The derivative of negative p is just negative 1. And then for this piece, we need to use the quotient rule. So I set up my quotient rule where f of x is equal to 4p, f prime is equal to 4, g of x is p plus 3, g prime is 1. Be careful, leave your negative on the outside and deal with that at the end. So we have negative 1 minus g times f prime plus f times g prime all over g squared. When I go through and I simplify, my final derivative is going to equal negative 1 minus 2 over p plus 3 squared. Since I'm looking for the rate of change at 5, I plug 5 into the the derivative function. When I plug 5 into the derivative, I get negative 1.1875. The sentence that I'm looking for is the demand is decreasing, since it's negative, at a rate of, the demand is going to be a dollar amount, so decreasing at a rate of $1.19 per unit when the price is $5.